Okay, we're going to do a little refresher on the Pythagorean theorem. Before we actually do the Pythagorean theorem, I'm going to remind you how to do the Pythagorean theorem backwards. So we know to use the Pythagorean theorem, it has to be a right triangle. So if I have a triangle and I know all the sides, but I don't know if it's a right triangle, we can use the Pythagorean theorem to figure out if it's a right triangle or not. So if in this first example, this triangle, our side lengths are 5, 6, and 8. So we know if it is a right triangle, then 8 is your hypotenuse, your C. So I guess I should have started with the Pythagorean theorem is a squared plus b squared equals c squared, where C is your hypotenuse, so it's the longest side of the triangle. It's also the side that's across from the right angle. So if this is a right triangle, then this is the right angle. All right, and it doesn't matter which side's A and which side's B, as long as you have your C labeled, your hypotenuse. So we know it's going to equal 8 squared. And so it doesn't matter which order these go in. So I'll do 5 squared plus 6 squared equals 8 squared. And then 5 squared we know is 25, 6 squared is 36, and 8 squared is 64. So we don't know that this equals 8 squared. That's what we're trying to figure out. So if the Pythagorean theorem works, if a squared plus b squared does equal c squared, then we know it is a right triangle because the Pythagorean theorem worked. But if the Pythagorean theorem doesn't work, then this is just a plain old triangle. So if we take 25 plus 36, do we get 64? And the answer there is no, we get 61. So this is not a right triangle. And that's how you would prove it. All right, so let's do another example. This time I didn't give you a triangle to look at. I just told you that A equals 3, B equals 4, and C equals 5. So that's giving you the 3 side lengths. So to use, we know this is going to be our C squared. It tells you it's C, and also it's the longest side. And you'll always label your longest side as C. So we'll do A squared plus B squared equals C squared, 5 squared. And we're going to see if that does work. So 3 squared is 9, 4 squared is 16, 5 squared is 25. And if we take 9 plus 16, we do get 25. So in this case, the Pythagorean theorem does work. And so that means that this set of numbers does in fact make a right triangle. And now we're actually going to use the Pythagorean theorem. We know that it's a right triangle. We're missing one of our sides, so we're going to use the Pythagorean theorem to find it. The one difference now is I don't want you to give, if it doesn't come out nice and pretty, I don't want you to give your answer as a decimal anymore. I want you to simplify it, simplify the radical. So a squared plus b squared equals c squared. In this case, the x is your c because it's across from the 90-degree angle, which means it's the hypotenuse. So we've got a squared and b squared, 3 squared plus 6 squared equals your c squared. That's the side we don't know. We don't know our hypotenuse. So continuing to solve, we have 9 plus 36 equals x squared. That's a bad x. 9 plus 36 is 45, so 45 equals x squared. When you get to this step, don't forget to take the square root of both sides to get x all the way by itself. Now the square root of 45, it's not a perfect square, so instead of getting your calculators and rounding that to the nearest decimal, we're going to simplify that radical. So remember to simplify your radical, you're going to make a factor tree. So I'm going to use 9 and 5 to start. And then 9 splits up into 3 and 3. So now here are my 3 prime factors, 3 times 5. So my 3's buddy up, 1 dies, 1 escapes, and the 5 didn't have a buddy, so the 5 is left behind. So our answer is 3 root 5, which is the same thing as the square root of 45. In our last example, again, we have a right triangle, so we're going to use the Pythagorean theorem, a squared plus b squared equals c squared. This time, I do know the c. So I know that 12 is c. It's our hypotenuse, which means our whole thing is going to equal 12 squared. What we don't know is one of the legs. And it doesn't matter whether you make that your a squared or your b squared. So I'll do y squared plus 6 squared equals 12 squared to set up the Pythagorean theorem. Then continuing on, we have y squared plus 36 equals 144. So when one of the legs is missing, it just requires an extra step. We've got to subtract this from our hypotenuse. So we're going to subtract 36 from 144. So we get y squared equals 108. And then to find y, we take the square root of both sides. So we have the square root of 108. Now, I know 108 is not a perfect square because 10 squared is 100 and 11 squared is 121. So 108 is somewhere between 10 and 11. But instead of writing it as a decimal, we're going to make our factor tree again. And if you don't know where to start, we know this is an even number, so I'm just going to do 2. So 2 and 54. Then 54 I know is 9 and 6. 9 is 3 and 3. And 6 is 3 and 2. All right, so I'm going to go ahead and circle all my prime numbers. So I have 2 times 3 times 3 times 3 times 2. All right, now we've got to buddy some guys up to break out of jail. So I'm going to have these two 3's buddy up together, but don't forget to kill one off. And then I've also got 2 2's. These 2 2's can buddy up together, but kill one of them. So what we have is a 2 and a 3 that escapes. So that means 2 times 3 is 6, so 6 escapes. And this 3 didn't have a buddy, so it is left in the radical jail. So y is the square root of 108. It's also 6 root 3. So our final answer would be 6 root 3 since that is in simplest form.